Live. So, welcome to another episode of streaming. No, I'm joking. Not doing streaming clouds anymore. I'm today joined by Wesley. Wesley, welcome.
Thank you.
What do you have for us today?
I've got a story on container image security, which I can do in 20 minutes or 24 days, probably. So I hope I picked the right stuff for you all. Uh,
All right, sweet.
let's do it.
Let's get started.
All right. So I've got a couple of sheets, hopefully, to explain some stuff, and then we're going to dig into some GitHub actions, Azure Container Security or Azure Container Registry, and some beautiful YAML, which I've got accustomed to in the past couple of years. First things first, Wesley Haakman, Principal Azure Architect at Intercept, Microsoft Azure MVP. Recently picked up blogging again, which, I did about I did 5 parts on container image security. I'd probably like to do 20, but I'm going to stick to the 5 and then probably start a new series at some point. If you just want to chat with me, reach out. I'm always happy to chat about anything cloud native, Azure, containers, you name it. I'll talk about it. So, uh, container image security. The big question is why? Um, I started digging into this, and I've got an ops background back in the day. I mean, I've been in IT for 20 years. That's really painful to say, but I've been in IT for 20 years. And I started with Linux, VMware, and I even did some Novell NetWare a long time ago, but um, mainly just, operating systems, managing servers, and then at some point virtual machines. And what we always knew was things like, Patch Tuesday, and when CVs came out, we dropped everything and we patched our servers, whether that was Linux or Windows. And that was a common thing among ops people, patching your stuff, make sure everything is secure. So we respond to CVs, we patch, and then we just continue our daily business. And then at some point, containers became a thing. They're awesome. You can do amazing things with them. They're extremely scalable. But we still have a container image. And I always like to tell the story that, containers are just operating system virtualization. They're still an operating system inside that container image, even though we limit it to the bare minimum that we need, just our libraries, our packages, and, a kernel in case of Linux containers, or a little bit more when we do Windows containers, but let's leave Windows containers for what they are right now. So what I see a lot is, we've got a process for patching virtual machines, but what about container images? Do we even look after them? They became so popular, but do we think about that? And there's the problem, because if we look at virtual machines, they scale less. If we look at containers, one of the added value there is extreme scalability. If you look at orchestrators like Kubernetes, we can go from one container to 1,000. But if we don't take care of our container images, we can scale a problem from one container to 1,000. We can make a small problem very big. So our problems are going to scale as well. So why are we neglecting our container images? Why are we not taking care of them? And that's down to the process and mindset. If we look at ops, we were trained to look at those operating systems, install patches, maintain them. If we look at containers, they are built from pipelines. I mean, no virtual machine 15 years ago was built from a pipeline, from a YAML file somewhere, and ended up running on your VMware platform. No, we installed them and we took care of them. And now we have a process, a DevOps process. We've got CI/CD. We've got a different mindset. And we just put a Docker file somewhere. It builds, and then it's being published to a registry. And then out of nothing, it runs on a platform like Kubernetes. And it's not always just the ops people dealing with that. I think when Kubernetes started becoming more and more popular, it was mainly developer driven. Developers thought, containers are amazing. I need an orchestrator. Let's do Kubernetes. And with all due respect, developers in their mindset were not the people patching those virtual machines back in the day. So, and that's fine. I mean, different disciplines, and then we had the whole period where they just chucked a group of developers and ops people in the same team and went, "You are now DevOps." That also didn't work. It's a shared, it's a shared thing. It's a shared responsibility, and ops people need to be trained better and more to deal with those pipelines. And we see that becoming bigger and bigger with the concepts of site reliability engineering, platform engineering. That is shifting. But now we probably have a little backlog of container images that need patching. To be fair, within the pipeline, or when someone writes a new Docker file, they like to go with things like the tag latest, so the latest operating system is used, and you should be good most of the time. But then they end up in a registry. And what happens then? They end up in a registry, it's there, we'll leave it as is. But then, as we know, every other day, new CVs are being published, and it might just affect your specific operating system or the packages that you're using. And those packages might be in your image, your container image, that is used to run a container on your orchestrator that provides your solution. And that's the problem, because we no longer look after those images because they're built, they're pushed, they're in a registry, and we're good to go. And from now on, we'll just look at the YAML or the Helm charts, the Kubernetes manifests, whatever you want to do. We just look at that. We no longer look at the container images inside the registry. The number of times I check with new customers that already have a container registry, and I enable Microsoft Defender, and I look at what's happening. It's just here and there, I still find vulnerabilities from 2 or 3 years old. It's log4j still a thing amongst container images, and that's the big problem. That's the big problem that we need to take care of. So
interesting, because now I'm thinking about it. Like, hey, you don't pull a container image from your registry, patch it somehow, and push it up again, right? Or you reboot it or something. It's not a thing, right? So it's in your registry. It's just sitting there. If you update it, using the latest version, or you start patching your libraries or whatever you're using, right, inside of that container, that means you also need to do some maybe QA testing, acceptance, whatever process you got going in your company before it ends up in production again, right? And back in the day, that wasn't really a thing when we were patching servers, right? You just patched it, you reboot it, made sure you did it, in the weekend or outside of business hours, right? And then you looked at the event log, ignored a lot of warnings because you had no idea what you were looking at. You're like, are there any weird errors? No, services are up. Yeah, okay, application starts. Yeah, I think we're good. All right, good. Yeah. And that's it, right?
And then maybe even that was on Windows. You would go to, depending on the application, you would go to help info and check, all right, is this the latest patch version? Yeah, all right, we're good to go.
Yeah. Good. Exchange patched. Let's go.
I'll see you tomorrow. Yeah. But that is indeed one of the biggest problems. And then the other problem, which we haven't even talked about, is if a container image has been, if a Docker file has specific versions, so a specific operating system version or specific packages, what happens when you update them? Is that going to introduce breaking changes into your application? The developer writing this, because what we put in a Docker file is the bare minimum, right? We need these specific packages, and we want to make that container image as small as possible. So they select specific versions, not even always the latest version, and then write their application and push that code to the repository as well. What if we update one of those dependencies? Will the application still run? So, like you said, there's a whole process that we were not used to, except for Java. Back in the day, when you would update Java on a machine, you would probably need either the partner providing the software or a developer to take a look at, does this thing still work? Because
the GRE runtime, was it?
Or yes, not? The GRE.
The little coffee. Oh man.
Oh. Yeah. Okay. Next slide.
Yeah.
Next slide.
That's it.
Yeah. So we can do a couple of things, and that's why I wrote a series of blog posts. We can do a number of things to mitigate those challenges. We can detect vulnerabilities in our registries. We can sign images and mark them as trusted. Hey, I've signed that image. I trust that that image is secure and I know what's in it. It can be deployed to my environment. We want to prevent untrusted images from running on your cluster, because signing an image and detecting whether it's trusted is one thing, but maybe we even want to prevent it from deploying. We can patch vulnerabilities in a container image. We can patch them without rebuilding without writing a new Docker file. We can live patch them. We're going to demo that today. That's pretty cool.
That's like,
yeah, it's
yeah, I've
we're
seen
gonna
it before. It's crazy. Yeah.
it's amazing. And we want to scan images in our CI/CD pipelines. And really, the overall strategy is, how do you combine these different strategies depending on your development process, depending on your requirements, depending on how many times do you want to build an image. In the end, you want to do all of these. You want to make sure that you detect what's vulnerable inside your registry. You sign your images when you trust them. You prevent untrusted images from running on your cluster, and you patch what's in your registry once it becomes vulnerable. Now, I see Richard is there. I was having a discussion earlier with Richard, and I'm a bit bold about this, but you could say I could build a container image, and in my pipeline, if it's vulnerable, I will live patch it. You could do that, but then my opinion is, if you're building a container image and it's vulnerable, don't even push it at all. Go back to the developer, deny the pull request, or back to the drawing board, fix that image. But that depends on your strategy. I mean, there's also very big enterprises with very complex CI/CD pipelines where that's probably not an option. But I mean, if you're starting from scratch, that's what I would do. And we definitely want to scan images every single time we run a GitHub workflow or an Azure DevOps pipeline, or what you want to do. So we've got a couple of technologies that can help us with that. And first things first, I'm a Microsoft Azure MVP. I love Azure, so I use Azure Container Registry. That's where we store our images, and it's got a lot of features that will help you leverage the other technologies. You want to use Microsoft Defender for Cloud, and specifically the new vulnerability assessment solution, which will go through your container images and very detailed will tell you what's wrong with which package. So Microsoft Defender for Cloud, Azure Container Registry, and then we're going to dig into some awesome CNCF and cloud native and open source stuff. We got to use Trivy. I mean, there's a lot of different solutions out there for container image scanning. I really like Trivy because it works out of the box, the Trivy action. It supports a number of different registries, so you're not limited to just Azure Container Registry. You can go above and beyond. And the cool thing, we're not going to demo that today because we're going to work with some JSON files and pass information to COPA for image patching. But Trivy can also output to your GitHub Advanced Security. So if you've got that Advanced Security in GitHub and you've got that tab security with all the vulnerabilities found and alerts and recommendations, it can even write to that. Out of the box, it's a 5-minute thing. It's amazing. It's very fast. You can use it in your pipeline. You can use it locally. So Trivy for container image scanning. And then if we want to sign container images, we can use Notation. And Notation will allow you to, with certificates, sign a container images. This also works great with Azure Key Vault and with Kubernetes. And you could go as far as then to implement Redify. And Redify is a very, very cool solution. You can leverage that in multiple ways. One of them is when you want to use image integrity on Azure, which is currently in preview, which it will detect, is a container image signed yes or no. You can enable that through a feature. You have to enable the feature on the command line in your Azure subscription. And once you apply the policy and it becomes active, it will deploy a Redify pod into your Kubernetes cluster. And then when you have container images running that are not signed, your Azure policy will show, hey, you have container images that are not signed. This is the list of images. It's still in preview. I like it. I have some questions on using it together with some other Redify features. What I found admirable is from the start, when you do the Azure policy, it excludes like your kube system and stuff because they're not signed images. So you're not getting a list of false positives that you need to deal with. You can really scope it to that what you need. That's what Redify does. It leverages Gatekeeper, which comes with Azure policy. This was the challenge about, I'd say, pre-October 2023. Because what you need to leverage Redify with Gatekeeper is a feature called, um, I think it's like something external something. You need to call external entities from Gatekeeper. That's a property that is supported in Gatekeeper itself, so you can install it with the Helm chart. But that option was not available when you enabled the Azure Policy add-on, so it wouldn't work out of the box. But they fixed that within a couple of months, and then that was pretty good. And then we've got Copa, which is also a something that people at Microsoft came up with. I think it was January 2023, and then there were several versions, and we're now at version 0.60 or 0.6, and recently became a CNCF sandbox project. And I think that's what I like about Microsoft and open source and cloud native. They're donating more and more and more. I think that's very cool. And what you see with Copa especially is that that's being picked up very fast. People love it. Within months, there was a fully fledged GitHub action. It's being actively maintained. Pull requests are being done. I really like that. I see a big future for Copa, but we're going to do a Copa demo in a little bit. And then we've got Azure Policy and Gatekeeper. Azure Policy, the add-on deploys Gatekeeper. It's the Microsoft Azure Kubernetes Service implementation of Gatekeeper. And what we see is that they keep expanding, or they keep adding more features, which allows you to include more CNCF projects that leverage Gatekeeper, because all the features are being enabled. Years ago, I was totally into governance, and I started with Azure and governance, and it was amazing. And then Azure Policy came, and I was happy about it. But then a couple of years, I didn't really touch it. But I'm getting excited about it again, because the way Azure Policy works with Azure Kubernetes Service and Redify notation. If you want to decline images from, and there's good Redify documentation on this, but if you want to deny specific images from being deployed because they're not signed, then you can do that with Redify, and you get a custom Azure policy that will you can manage that through Azure Policy. So you deploy Redify from the Redify documentation. It taps into Gatekeeper that's being deployed by the Azure Policy add-on, and then you can run custom Azure policies or deploy custom Azure policies to make sure that Redify does what you want it to do. So upon admission, deny the deployment of that specific container image because it's not signed. And that tells me that especially the AKS team and the container teams within Microsoft are heavily invested in anything cloud native, because that support is skyrocketing. That's what makes me excited about those solutions. A lot of other solutions out there, but the support for these is amazing.
So does that mean that if you go to signed images and you implement Redify as well, so that nothing unsigned runs in your non-excluded namespaces, right?
Mm-hmm. Yeah.
Does that mean you also pull in third-party images? For example, you deploy Flux. Does that mean you pull in the Flux image or images, because there are different controllers and etc. Yeah. Scan them, potentially patch them, sign them, so that they can run in your cluster, or do you just exclude the Flux system namespace?
Yeah, I think by default the Flux system namespace is actually excluded from the policy, or as a default exclusion, because you can, the GitOps add-on leverages Flux, so I think that's why I put it in there. The perfect scenario would be you install Flux yourself if you want like optimum security, your enterprise grade Fortune 500, everything needs to be secure. You have a pipeline that pulls the image from Flux itself, scans it, if necessary, patches it, signs it, and then pushes it to your own ACR, and then that's where you deploy.
Oh, I'm not even sure you can provide your own self-hosted images to Flux, but it was just an example, right? More as in
Well, it's
how
it depends
far.
per solution, but I mean, if you want to take it all the way, then you
Yeah,
probably have to modify some Helm charts or start building some stuff yourself.
yeah, it's and that can be one solution, but if you have multiple, then eventually end up with a team just doing the lifecycle management of these community CNCF provided solutions right now. It's just okay. It's a matter of how much budget do you have and how high is security on the priority list, right?
Yeah, and then how far you're willing to go. I'd say for Flux is a good example. I mean, the GitOps add-on managed by Microsoft, it deploys to Flux system if you run it on AKS. I'm perfectly fine running that without signing it and excluding that namespace. I trust what they do at Microsoft. I'd be more worried about smaller projects, if you will, and things like supply chain attacks are a thing. So, yeah, you for anything non Kubernetes system or Flux system or you know what I mean, non add-on, I would probably look at the image signing. But it is a hurdle to take. It's not the first thing you're going to do. Let's be honest. It's quite some steps you need to get used to it. I've been at this for a couple of weeks, and I'd say that last Saturday, I'm like, oh, I can just command line deploy this, that, and do image signing and do all of that. Up until then, I had to revert back to my original documentation to get it right. It is something you need to do a lot and get right before you should put it to production.
That makes sense. Yeah. It's just it already spirals out of control in my head, right? Like, oh, how far do you take this and this and that, and security is as strong as your weakest link, and blah blah blah, right? So, but yeah, you can go completely bananas.
Oh yeah, definitely. Yeah. So what I did is to make it a little easier. So what's the use case? When do you use which solution? If you want to scan for vulnerable images in your registry, use Microsoft Defender for cloud or vulnerability assessment. If you're using another registry, I mean on Amazon or GCP, they've got similar features. You can always use Trivy to pull an image from your registry and scan it as well. So if you don't have a feature in your registry that, like Microsoft Defender for Cloud and the vulnerability assessment, you can always use something like Trivy to scan it continuously, set up a GitHub workflow with a cron schedule, do it every so now and then, depending on the budget you have for your GitHub runners or Azure DevOps agents. But, and scan for vulnerabilities in your CI/CD pipeline. That will be Trivy. You can pull something from an already built image, or you can build the image in your pipeline and then run Trivy, and it comes back with results. If you want to sign container images and mark them as trusted, you use notation. If you want to patch existing images, you want to use COPA. If you want to validate whether an image is trusted and signed on deployment, or in Kubernetes language, we should say on admission, then you use Redify. If you want to detect vulnerable images running in your cluster, it's AKS image integrity, which is in preview. Mind you, AKS image integrity, the preview feature, deploys Redify, which conflicts with using Redify yourself. So that's the thing. They're sorting that out. I mean, it's still in preview and lots of stuff is being updated. That will probably be sorted in the future. But for now, the bottom two, they do conflict with each other. That's good to know, because you got two different Redify implementations, and you will go install Redify and do all the amazing stuff to, modify the admission process, and the Helm chart will go, well, you already have Redify, so you need to unregister that feature before you, or heavily modify Helm charts, which you could do, but then, maintain it, upgrade it, update it. That's probably not the best. All right. And then we're going to take a look at two demos I prepared. I prepared one demo with Trivy. We're going to scan a pipeline. We're going to build a container image and then hopefully reject or block a pull request from merging because there's vulnerabilities. And we're going to live patch an image using COPA. And then hopefully Microsoft Defender will tell us there are no longer vulnerabilities. So with that, I'm going to start, and let's see, which website is that? Let's open this one. See, I clicked the right one. That was surprising. So we've got one repo here, container image security, and we have a Azure Container Registry here, and this is what we'll check out later, but we already have an ACR, and what we already did is set up our GitHub repository secrets to sign into Azure and log in, do a Docker login, and push to ACR. So if we go back to our initial repository, we have 2 Docker files, and let's show them. We have one Docker file currently from Golang on 1.16.9-Alpine, which I can assure you is vulnerable to quite some things. We kept it small, works for a demo, builds quite fast. And then we have a good Docker file which builds BusyBox, the latest. And let's hope that just didn't become vulnerable in the last 5 minutes. It worked an hour ago, but we'll see. So then we have our workflow. We have 2 workflows here. We've got Trivy. And what we're going to do is on a pull request to the main branch. And this boils down to strategy, right? What do you prefer? Do you want to merge first or do it in main? Or this is your development and CI/CD process. There's no rights or wrongs here. And what we're going to do is just use we're going to build an image from a Docker file, which is the Docker file that we have. And then we have a Trivy vulnerability scanner. And this is going to output stuff in a table. This could also be sans serif and then push it to GitHub Advanced Security. We're going with the table, and we're going to throw an exit code 1 when we find vulnerabilities, because we don't want to allow someone to merge the pull request. And ignore unfixed is true. So if it's not fixed, we're still going to ignore it. And we're going to look at the OS and library vulnerability types and just critical or high. So what's going to happen is if I've got my Docker file here, which is not the best, we just merge it and we go, we're going to create it, we're YOLO, and yes. And we sync it. I read a blog post today on someone that wrote very good commit messages and like 5 best practices. And I thought I need to learn about this stuff.
You can use GitHub Copilot to write your commit messages.
Oh, I never done that. I will. This is going to merge and stuff, but I'll show you. I was playing with Copa, and then I learned I need to write better commit messages. I write things like this, sketchiness, more sketchy thing. I need to learn from those best practices and probably use GitHub Copilot as well. So let me see. I didn't even see, I did it wrong because I'm not supposed. Did I do it? To which branch did I push it? Let's see if we can do a pull request. No, we didn't. See, I made a boo-boo. Let's open up the. Oh, what am I doing? I should create a branch. So we got the same Docker files here, right? Of this Docker file. We're going to git checkout, and we call it demo 1, 2, 3. Oh, and then we got this. I'm going to code the README file. Just live demos, love it. So we broke it. And if we're going to take a look at this, we've got something new. All right, we're going to do a git add, a git commit. Sorry, push origin demo 1, 2, 3. And now we should be able to do a pull request. There we go. Pull request. So we're going to merge this into main. And if we are going to create a pull request, that's when Trivy is going to run, because we set on pull request to the branch main. It should start checking stuff. If we look at the files changed, sorry, you fixed it, sorry, you broke it, but we already had the vulnerable file as a Docker file there. I'm just double checking if we did. Yes, we did. So it's going to do some checks here. Sorry. And then we just wait. The check has started. If we look at the details, we can see it already failed. Why did it fail? If we take a look at this, we can see that Triffy went, well, this is probably unreadable, but bear with me. It found a bunch of vulnerabilities, and that's not a good thing. So when we set exit code 1, that's when it just stops and fails. So we cannot merge. We cannot merge this. Now, if we go back and we're in this one anyway, and we're going to, so this is the Docker file. Only wrong, we've got the good Docker file. So we're going to delete this Docker file, the original one with the vulnerable thing. And we're going to move the good.docker file to Docker file. I'm going a little bit fast, but now if you look at the Docker file, we can see new Docker file. So we're going to git add, git commit -m, git push origin demo 1, 2, 3. And what's going to happen is, because we did an update and we go back to our thing, is going to start scanning again because we just updated the branch that's in our pull request. It's going to run again, hopefully not find any vulnerabilities, and then that will allow us to continue.
Does it scan does it build the image and then scans the image?
Yeah.
Okay.
If we're going to pull it from in the next demo with Copa, we're actually going to pull it from ACR, and then you need some additional configuration for Trivy, so it actually logs in and then pulls it. Just getting ahead of ourselves, with Copa, we could technically do the same to actually build it in our pipeline and then have Copa patch it. But that requires some features that are disabled by default on GitHub runners. So you would need a custom agent where you have some amazing containerd stuff that is not by default configured on GitHub runners. I saw a series of pull requests in the Copa action repository the other day where they are fixing this. So that should probably work out of the bug soon as well. Well, so it's scanning again. One of the things that I did enable is that I can bypass my review process, because demos are usually done by one person, or else I would have to pull someone in and approve my pull request. Don't do this in production. You don't want to do that. So it's going to run, check again, go, all right, I did not find any vulnerabilities, and then you can push it to ACR. And that's the second GitHub action we have configured in this repository on push to main. And if this process works, then we trust that this has been scanned, nothing has been found, so we're allowed to merge. Only then can you do a push to the you push it to ACR using a separate workflow. That also boils down to what strategy do you want, right? Do you want to rebuild it again? Do you want to do ACR build? Do you want to play with quarantine settings in ACR? That's totally up to you. This is the old one. We were looking at an old screen. I should have F5. If we look at this one, we can see it did the check again. One successful check, which means that if we do this, Trivy build it successfully, did not found any vulnerabilities, and we merge it. We confirm it. It's going to merge, and then what's going to happen is a new action will run, merge pull request, because that's just going to push it to ACR, or build it again, push it to ACR. And that's when you do it inside the CI/CD pipeline. You can do it from different branches, just in main, maybe even have a security branch, whatever your branching strategy is and your CI/CD process is, you need to fit Trivy in there somewhere. And you can see it's quite easy. It's a very small action, doesn't require a lot of things to figure out. The documentation on the Trivy GitHub action is great. It's very detailed. There's so many options that I did not even explore. Um, so yeah, definitely use that. So that's Trivy. So that's when, if we looked at the sheets, that's when you scan images for vulnerabilities in your CI/CD pipeline. Someone developer comes, new Docker file, it builds, it's going to scan. Is it good? Yes or no. Is it not good? Reject the pull request. Hey, buddy, please take a look at the packages that you're using because it's probably not the best.
Will it fail on each and every CVE, or just on the critical ones? Or
What we did in this workflow was look at high and critical. You could also set it to just critical, or even different levels. Depends on how strict you want to be.
okay, so that is configurable then.
Yes, that is
okay.
configurable. And if we look at the workflows we have here, so we've got Trivy. If we scroll down here, you got severity, critical, and high. That's what we're checking on. It's always a thing with CVs. I mean, I think today or yesterday, Microsoft released a information on a CVE for Azure File Sync, and I read about it this morning. And when I was reading that, it goes, oh, it's very high, but then if you look at exploitable, not very likely. I mean, what is high and what is critical these days? That's for you probably have a security officer with, some insights or an opinion or a document that says this is acceptable and this is not acceptable. In the end, it's all risk management, right? What's the risk? What's the likeliness of something to be exploited, and what does it cost for us to mitigate? Luckily, with container images, it can be very cheap to mitigate because we've got COPA. You see what I did there? It's a little bridge. So, COPA. What I've got here is COPA. I've got a very, very big workflow. And this also boils down to how detailed do you want to do this and what's your versioning strategy. But what we're doing here is we have a GitHub workflow. And on push to branches main, you could also do on pull request, whatever you want. But for now, we're doing a push to the main branch. I've got a job. I called it Patchy Patch. You just see my commit messages. At some point, I got very tired of all the stuff I was doing, and I just started making up random names. And apparently, I left Patchy Patch in there. Runs on Ubuntu latest. We've got a strategy because we're using a matrix. We can do one or multiple images, or you can pass like a parameter. Hey, scan this image. If you're going above and beyond and you're doing a GitOps and writing your own Flux stuff and your own customization and you're doing all that, you could probably go, all right, so someone commits a new image version in some file, grab that name and then run this GitHub action with that file name because running an ACR, you could do whatever you want. For demo purposes, it works if you have an image hosted somewhere and it works. So we've just got one image. We could do 10 or however much you want. That's what the matrix is for. And we're going to start with a Docker login. So why not ACR login? This is because, COPA is relatively new. And the original Azure or the original GitHub action I was using used the COPA action, which is a Docker container GitHub action, which, then it overcomplicated stuff, and I need an easy way to pass credentials from my Docker login. So I needed this, but ACR login technically should do the same. But before I got this working, I even tried to customize the Docker configuration with additional features, and then this helped. So we do a Docker login or ACR login, whatever you want. We log into Azure, and then we're going to run Trivy again. The change that we did is we set it to format JSON, and it's going to output the results to a Trivy results.json file. We're still doing critical high. We're doing operating system, ignore unfixed is true. What we're not doing is that exit code. So if you find a vulnerability, don't stop because we want to go to the next step. So then, and this is copy pasted directly from the original GitHub workflow from the COPA action, is we're going to check the reports file, trivia results.json. We're going to check what the vulnerability count is. So anything bigger than 0 means that Trivy detected something. Now, then we're going to check if the output, so if the vulnerability count, which we're outputting here, is bigger than 0, we're going to run COPA patch. And COPA patch, and I at some point did not go with the default GitHub action because buildx and other stuff were conflicting on my GitHub runner. So we're grabbing the binary, we're installing it, and then we're going to, and this boils down to your versioning strategy. And if you're going to deal with this, ChatGPT 100% makes this a lot easier, or Copilot works as well. We've got an image name, which is being passed from the matrix of images. We're going to store the image name and the tag, because if we now have a v1.01 running, then we want to patch it, and then we want to go to v1.0.2. We want to just go up one version, or maybe you push things first and you tag it with -unpatched or whatever you want. So it's down to your versioning strategy. So we're using AWK to pull apart our tag, and then we're going to do for the patch version, patch ++, so the 1 becomes a 2, or the 2 becomes a 3, or the 3 becomes a 4. And then we're going to create a new tag, and we're going to echo that as output. And then it's going to do patching. Technically, what COPA does is just this. This is COPA. It's a binary. It can run in a GitHub action as a canary action. All the other magic is preparation. This is COPA. It's an amazing tool. It's very stable. So we're going to patch that specific image. And we're going to look at the report trivia results, because that's what we found. And then that it results in a new image, or, well, yeah, an updated image with a new tag, which is the patch tag, which came from our AWK bash scripting magic. Then we're also passing a COPA version. This is the latest version, 0.6.0. If you're using the original GitHub action, you would do like latest, or you could use that as a version as well. So that runs, and then it's going to push the patched image, and we're just going to Docker push. And this is where we need those outputs. COPA patch outputs, image name, patch tag, and then that should end up in our Azure Container Registry. Now, if we can start this process. No, before we do that, because this goes pretty quickly. We now have a backend version v1.01. And if we take a look at that, this is the same Golang image that we used. There's, there's 3 pages, 21 vulnerabilities, or 21 things that need patching. So technically, if we now run COPA and we let it check for this specific image, this one, we should end up with a .2 patch version with no vulnerabilities. How we're going to do that is we're going to go back to this one, and I'm just going to add a dot to trigger it. We're going updated something. Still no good at git commit messages. Yes. See the changes, and now if we go to the repository itself, it was this one, and we refresh, we should see updated something. Well, that's what we updated. Now if we go take a look at our action, it should start running. We see this is the matrix with just one image, so patchy patch is going to run. It's going to log into Azure and hopefully patch our image without building something from a Docker file. So Trivy is going to scan. Docker log into Azure. Trivy is quick today. This actually runs pretty quickly. It's going to check the vulnerability count, and then if that count is bigger than 0, it should start patching stuff. So it found something because COPA patch is running. And this goes pretty quickly, but you will actually, if you scroll through it, once it's done, you will see it's just installing stuff inside the image.
So it layers and it adds another layer with the patches or layers actually.
Yeah, you can. It pretty much just pulls it apart, and so you can see underwater what it's doing. Like here, APK update. So it found the image, luckily. And then if we scroll far enough, this is going faster than it's good for a demo. Somewhere there is a list of commands that you will see. It's actually actively updating, and you see here, so it's updating libcrypto, which we saw in ACR as well, and it just builds a new image. But that's what it does. So then it's going to run a patched image, and if we or push a patched image. Now if we take a look here, refresh, we've got a v10.2. We have a new image. And if we go back here, I didn't scan the other one yet. It takes a couple of minutes, but if you check my blog post, you will see it will not find a single vulnerability. It patched everything. Yeah, if we go, we can see if we can load it again. Maybe it already did that. No, scanned images still just one. So it patched it, it pushed it. We have a new version. But what this doesn't fix, and that's important to know, is that original Docker file living somewhere in a repository deployed by or written by your developer or your DevOps engineer with those vulnerable packages, right? This is merely mitigation, not prevention. Prevention is when you fix it in the Docker file. So depending on your strategy, this will work for you or it will not work for you. I think COPA should just be a default feature in your CI/CD pipelines, because even if everything is already patched from the start, someone might miss something. You still want to push to production as fast as possible. When we're always talking about time to market, or I like to say time to value, push it out as fast as you can. If COPA can patch it, it's still secure. You could add an additional step, sign it with notation because COPA patched it, then deploy it to your cluster. That's depending on the strategy that you wish to follow.
What is the success rate of COPA? Did you ran into something that you were not able to patch with COPA?
Yes, very, very old, unmaintainable packages. What I did for modern stuff, you should be fine. What I did the first couple of tries, also on command line, was OWASP, the organization, has a very good vulnerable container they use for CTFs, which has got like hundreds of vulnerabilities. Also, really, really old stuff that, if you're installing that legacy stuff, you just stop with IT. That's so old that's not likely to happen in a container, right? But it's good for CTFs, like entry level exploitation to play with. That was so old it wasn't really recognized by package managers, or it just didn't work out of the box. For most modern stuff, no false positives, no breaking stuff, and it patched everything. And you could even, you configure it that, it could patch, if it could patch 90% and just a couple of packages you couldn't patch, you could still decide to just patch those and still push it to ACR. Then yes, you do have vulnerabilities, but how relevant are they? That's also the thing, like how relevant are those vulnerabilities? I don't want to take away any urgency here, but you see a lot of containers running in Kubernetes that are completely isolated from the rest of the world, and someone is not likely to access that container, and it's just like a backend process. It just receives something, and you've got network policies, and then you've got RBAC, and anything is not likely to be exploited. You also need to take that into account. So then if you cannot patch it, is that necessarily a problem if redoing it means 6 months of development? You still want to have like the number 0 when it comes down to vulnerabilities, but there's always a story behind it on whether you should do it or should not do it. But if you're just refactoring something, you're starting from scratch, there is absolutely no excuse not to implement any of these strategies. We can see that it scanned images, it scanned it, version v2, and it says no data. And first I thought that's broken, but no data means it did not find any vulnerabilities. We had the 3 pages of vulnerabilities. Now we have 0 because it's patched by Copa. It was a small image, I know, only took a couple of seconds, but even with bigger images, it doesn't take as long. It's pretty quick. I think that's, I know I built it. I finally got it working the way I wanted to, like repeatable, because you cannot blog about it if you cannot repeat the process. You throw everything away. Let's do it again. Does it still work to your liking? Yes. Okay, then you can blog about it and have other people play with it. I think I deployed it over like 20 or 30 times over the weekend, and it was very stable. Very stable.
20 or 30 times over the weekend.
Well, it's just deleting and then pressing play on a workflow, right?
Sounds like my weekends sometimes. Yeah.
Yeah, just usually like my Sunday morning. Yeah. Yeah, and with that, I mean, we're almost an hour in, and I can talk about this for the next couple of days probably. But no, we're gonna stick to that when it comes to demos and the story. And probably when I do a next video, it'll be Redify notation, or that's the cool thing about a series, right? You can just pick your different demos from your different articles and have a chat about that. But I think these are the 2 most important ones, or the ones that have the most impact and are easy to use. Trivy, scanning in your pipeline, and patching stuff that's already in your ACR. Yeah, that was it.
Sweet. Time flies. It's almost 6. Yeah. All right, man. Yeah, this is awesome stuff. It Copa, you told Copa just patch, or Trivy just scan for OS vulnerabilities, right? Operating system vulnerabilities. Is it able to do that for applications as well?
It just scans packages and so the operating system and the packages. When it comes to application, I mean, Trivy's got a lot of features. You can even do an SBOM, software bill of materials. If you want to check for third-party licenses that you're accidentally using in the open source world. Your custom application and code scanning, I might be mistaken, but the default GitHub action does not. But there are code scanning actions out there, especially if you use like GitHub Advanced Security. There's loads of them out there that you can add to this as well, right, as a step.
Yeah, because I think patching a compiled piece of software is going to be pretty hard to do, right? That means you need to compile it again because there's no other way. So
no, and you would probably need like some, depending on the application, right? If it's like a web application, you might want to do some fuzzing on the HTTP port and throw random data at it, random payloads. No, that's not what Trivy does. There are solutions out there that do that. Then the question is, that's also a good question. Do you want to run that in your pipeline? I mean, good fuzzing and sending payloads to stuff, it can be a lot of data. How much money are you willing to spend on your DevOps agents and your GitHub runners as well?
Good point. Oh man, yeah, like you said, you can talk about this for days. Probably we can do a marathon.
Oh yeah, I sometimes call up Richard and go, "Oh, look how cool this is," and then we're like 45 minutes in. Oh crap, need to get back to work now because we just get excited about it. There's so many things you can do and talk about. I think the challenge is having like a package that you can deploy out of the box. Like, hey, this is the pipeline with these features and best practices, and this is how you do it. Probably a good blog post. Yeah, see, Richard response happens often. Call each other stuff, right?
There we go.
Yeah, happens quite often. Yeah.
But this is work, right? In a way.
Oh, yeah. Well,
yes and no. Yeah, we can talk about
yes
that for an hour as well. Yeah.
Yeah, I mean, it's research that in the end will probably help you in your journey with customers. Well, I think that's also a cool thing about contributing to the community. You dig into new stuff, research about it, spend evenings and weekends but you're still excited about it once
Yeah,
it works, right?
absolutely. All right. Shall we wrap it up?
Yeah, let's do that.
Yeah, no questions. Oh, Richard, anything you would like to discuss on stream? No.
He was here last week, right?
Yeah. And then I catch you guys on the Cloud Native Weekly as well. So yeah,
Oh yeah, yeah. You should join that someday.
I would love to. It would be nice. Yeah. All right.
Well,
Oh, he says so. He
we'll
says
reach
something.
out.
What? Oh, all good. All good. All right. Well, then we'll wrap up. All right, man.
Yeah.
Wesley,
Thank you.
thank you.
Thank you for having
Always a
me.
pleasure talking to you.
Yeah.
Yeah. Let's see what we can do together as well. Love to come on Cloud Native and probably lots of other ideas. But yeah.
Let's do that. We'll reach out. Thank you.
All right. My pleasure. With that, see you guys later. Bye.
Bye bye.